Welcome to This Is My Architecture Live. My name's Tom from AWS, and today I'm joined by Cam from Splunk. Welcome, Cam.
Hey Tom, how's it going?
Super happy to be here at reInvent once again.
Same here.
Big week, a lot going on.
Oh yeah.
So tell us, what does Splunk do?
So Splunk is a big data platform. Basically, customers send any kind of data, structured, unstructured, and we give them the ability to search it and get value out of that data.
Really cool, really cool. It's a tool that I've used in my past life before I came to Amazon, so make a great product.
Awesome.
So we're going to talk about an aspect of your architecture today, and I see we've got a customer side and a Splunk side. Tell us what's going on here.
So on the left-hand side, you have a customer that's sending data into Splunk. They have multiple ways of doing so. Serverlessly, we support Lambda functions directly into Splunk, and also Kinesis Data Firehose directly into Splunk.
Okay, so a customer can use various AWS services to ingest that data and then start to drive their analytics and reporting based on that, or they can just send data directly into Splunk?
Yeah, absolutely. So we can send or collect data from AWS services, also their data, whether it be through a forwarder or again through these AWS services natively into Splunk.
So yeah, so let's just draw that up here.
Sure.
Show these data paths.
So
there you go. Try that one.
Thank you, sir.
There we go.
So again, traditional HEC data comes in through an elastic load balancer. Kinesis Data Firehose, it does go through a second load balancer because it does require sticky bits in order for the data to process properly.
For Firehose, yep.
Correct.
Cool. So we've got two data paths coming in here potentially, right?
Mm-hmm.
Different data sources. What happens to it after that? I see we've got EC2 behind it.
Yeah, so what we've done in Splunk Cloud is we've enabled the separation of storage from compute.
Okay.
And this allows us to have EC2 instances with very fast cache tiers that allow us to store the data here where customers are searching it, but then shuttle the data off into an S3 bucket if it's not being searched as frequently.
Okay, so it's going to come into one of these ELBs, it's going to go into EC2. Looks like this is in an auto-scaling group, so you can scale up and down?
Correct. You can scale up and down, but also it prevents any kind of failure. So it gives you resilience in case you lose an index or a search head in an availability zone.
So that's a great use of EC2, but why are you using both EC2 and S3 here?
Yeah, so we're using this because we're getting a significant, it helps with cost savings, but it also helps with resilience. So if we're leveraging S3 as a back end for essentially our clustering, it allows us to have multiple S3 buckets. It also allows us to do data replication. And the other good thing is that enables our new features, dynamic data self-storage, which allows customers to export their data directly to an S3 bucket in their account, or leverage this capability of archiving data in Glacier on AWS in Splunk.
Right, so how do you decide then what data is stored on EC2 and what gets pushed to S3 or to Glacier?
Very good question. So what we do here is there's a smart caching tier that evicts data as it's not being searched. Okay. So it's not really first in, first out. It's more if you're searching the data, it stays in the cache tier. We had a customer that had a dashboard that loaded in 14 seconds. Now it loads in less than 7 seconds.
Oh wow, that's a big performance difference.
Oh yeah.
So talk to us a little bit about the value. So performance is obviously one of the value aspects of having this multi-tier architecture.
Right.
What else was an impact of moving to this?
So data resilience was definitely another piece of the impact. Right. Giving customers flexibility on where they store their data, and obviously there's cost savings as well involved with this.
Right, because S3 is cheaper than the storage that you're doing on EC2.
Oh yeah.
And you get the data durability of S3, which allows you to then rehydrate the data in case you need it.
Correct.
Awesome. So, well,
so
what else do you have to tell us about the architecture?
One other component here is the Glacier aspect allows us to have a self-store, essentially the customers can rehydrate the data from Glacier through the UI.
Okay.
So this way, if they have this for a compliance need or they just need to store data in a short term, they can do that using the UI directly in the Splunk Cloud UI.
So then what about looking forward in the future? What would you like to add to this architecture?
Sure. So one of the things that we're looking at is using private link. So allowing customers to essentially send their data directly to Splunk without traversing the public gateway. using backend to send data directly in.
So they can have their data show up directly inside their VPC.
Correct, correct. And each customer does get their own dedicated stack. So all their servers, indexers, search heads are all their own.
Well, Cam, thank you very much for showing us your architecture today. It's a really interesting way to use multi-stage storage to solve some real-world problems.
Awesome. Thank you so much for having me.
And thank you for watching. This is My Architecture Live.